First, we will explain what the prototype design pattern is. The purpose of using this design pattern is to create objects that are easier to use, update, test, and reuse. The prototype pattern achieves this by allowing you to create a clone of an object. This means you create a prototype class that will make an exact replica of another class and store all of the information in a completely separate location in memory. This will allow you to choose which objects are created at runtime instead of compile time. The diagram here explains how this works. You start with your initial client class, which creates a product object. If you want to clone it, you send it to the prototype class, which calls the clone function. This creates a new object exactly like product, but stored separately in memory, and allows you to make several changes to the object. You now have an entirely new object without having to go through the typical instantiation process.
How this process applies to our calendar app. Well, first off, this prototype design process is perfect for implementing when we want to create instances of the same event, assignment, or activities over and over again across weeks or months and different periods of time. It allows you to change all instances of an event by changing one instance of the event instead of each one individually. And it allows you to change and create new events while using the app, which is really important. So you're probably wondering how this application of the prototype design process will actually apply to the calendar application. Well, first we'll find that as the user creates a new event, that event will be saved in a form in the prototype class. That class will, through the clone function, copy everything in that original event and create a new instance through which you can create repetitive instances of the original event. Now, if you change the first event, each consecutive instance of that event should change as well. This is the greatest benefit of the prototype design process in our calendar application, is that from just one point, you can change the times and the metadata, essentially, of each and every single event or assignment or meeting on that weekly or daily basis that we would have set up in our calendar. And this process will repeat for each and every event. Each event is going to create this prototype clone, which will become this blueprint to create each new instance of the original event. In the instance you see on the screen, we have created the original event from which we've created the prototype, and then created one new instance of the first event. This shows how, by creating the first event, you will also be able to create a second event. This can continue to create multiple versions of that event over and over, which will be essentially just copies of the original event. And that's how this prototype design process can really benefit our calendar app.
The following are some benefits to using the prototype design pattern. First, it allows the adding and removing of objects dynamically at runtime, which would normally occur during compile time. It also allows the instantiating of dynamically loaded objects. When used correctly, the prototype design pattern can sometimes be a more flexible alternative to the factory design technique. This is because the prototype design pattern allows you to choose which classes to use at runtime and modify cloned objects. The prototype design pattern also allows you to use any subclass instance of a superclass at runtime. It allows you to modularly test how your classes interact, and it reduces costly overhead of initializing an object.
So, some of the disadvantages of using this prototype design process are that the clone operation can be difficult and confusing to implement in the correct way. Some things that kind of coordinate with this is that are you copying the right event? Is it under the right hierarchy? Is the prototype that you are currently copying being used by anything else? And that's getting to our second problem, is that you have to keep track of the override on your current clone operation. And because you override that clone operator many times, it can get a little difficult to understand, what is currently cloned in your prototype. But outside of that, this is a fairly useful design process, and it's definitely something that we're going to need in our own application.
There are several instances where you would want to implement the prototype design pattern. You would want to use this when you would like to specify what classes are used at runtime instead of compile time. You would also use this when you want to instantiate dynamically loaded classes, and when you need a similar class to one you already have but do not want the new class to have any ties to the old one. This is because the new copied class will be stored in a completely different location in memory. You would also use the prototype design pattern when you have several classes that share the same data. The following is a real-world example of when to use the prototype design pattern. Let's say you want to open up a checking account at a bank. Initially, you will need to provide a lot of documentation. ID, social security information, etc. After some time, you decide that you would also like to open a savings account. Instead of creating a completely new object from scratch with all of the same information, you can use a prototype class which copies all of the previous data from the checking account into a new savings account object, which will have all of the information from before and also allow several changes to be made.